life of people and protect ecology on the earth while conserving the ozone layer and our environment. Our Ozone Day is observed to create awareness among the people and protect the depletion of the ozone layer. So, hence, it is celebrated worldwide. So, on this note, I would like to invite Dr. Suraj Kumar Singh to take forward today's event with a welcome address. Sir, you're most welcome.
Very thanks, Dr. Priyanka. Good morning, everyone. Greetings to one and all present here. I'm Dr. Suraj Kumar Singh. I'm currently working as an associate professor in Center for Sustainable Development. Welcomes you all. It gives me immense pleasure to grace you all your presence in the interest of the entire community. It gives me tremendous happiness to present the welcome speech among the most esteemed people listening us. The International Day for the Preservation of the Ozone Layer, or the World Ozone Day, is celebrated every year on September 16 to highlight the importance of ozone layer and raise awareness among the peoples about the harmful impacts of ozone depletion. The day acts as a reminder about the need to protect the ozone. It also brings us focus towards finding more efficient measures for the same. The theme for this year, World Ozone Day, is Global Cooperation Protecting Life on the Earth. The theme not only encourages sustainable development goals, but also recognizes the broader impact of Montreal Protocol. The day holds significance as the ozone layer that absorbs most of the ultraviolet radiation of the sun, and thus limits the amount of radiation that reaches the humans. Because if they reaches to us, those disastrous rays like gamma rays, X-ray, UV rays, we can have skin cancer, we can have various health-related complications. And the ozone layer play a very important in management, in reflectance, in absorptions and scattering. So the event is observed for the better understanding and addresses of sustainable development. I would also like to express my heartful gratitude to all of the members who have made this Ozone Day a grand success. And from this platform also, I would like to brief about my university. Suresh Gyan Vihar University is the best private university in Rajasthan with NAC A accreditation. We have successfully got ranked NIRF ranking from band 151 to 200, and the various courses that we are offering in this university are ranging from humanities, engineering, sciences, management, pharmaceutical sciences, agriculture, climate change, disaster management, geoinformatics. The center is also active in publications, as the center is continuously publishing papers in high impact factor journals, which are for the one of the best publication house in the world, like Willy, Science Direct, Elsevier, Taylor and Francis. The faculty is too good in the field of natural resource conservation and management, where we have got faculties from Central University, IITs, BITs, and other premium institutes of India. The center is offering various courses ranging postgraduate, undergraduate, and PhD. PhD in sustainable management, disaster management, geoinformatics, and geography. MSc, a postgraduate is the MSc Geoinformatics and MTech Geoinformatics, and at a bachelor level, we are offering BSc Geology. The center is regularly conducting various conferences, webinars, seminars, where the eminent scholars, scientists are coming up, sharing up their ideas, technology transfers are there, and the listeners are getting benefited from this, their understanding, their practical knowledge, what they have done over the year. And at end of the day, the purpose of any seminar or conference is for the sensitiveness, for making the aware the people what has to be done, what is being done, and what has to be planned. And that is the theme that we are looking up for the purpose of dissemination of knowledge, experience, information in all the form. And we are very fortunate that two eminent scientists, scholars, academicians, working in the field of natural resources, especially in ozone layer conservation and management, they are with us. and they will be sharing their ideas, their practices, their experience, what they have researched till date. And with this, I end my today's introductory speech. Now, again, I'll hand the session to Dr. Priyanka. Thanks, Dr. Priyanka.
Thank you so much, sir. Thank you for such a brief introduction. Now, I would like to take this opportunity to give a brief introduction of our guest, first speaker, that is Senior Assistant Professor, School of Earth Environment Science, Central University, Himachal Pradesh, Dharamshala, Kangra, Dr. Ankit Tandon. Dr. Ankit Tandon is an atmospheric scientist, and he did his PhD in statistical analysis of ozone column over India from JNU Delhi. He's also, received prestigious diploma in European research course on atmosphere from Joseph Frontier University, Grenoble, France, in 2011. Dr. Tandon was a visiting research scholar in North Carolina State University at USA between 2017 to 2018, and he has over 14 years of postdoctoral research and teaching experience. He has completed research projects from various funding agencies like SERB, DST, Niti Aayog, and so on and so forth. Presently, he has a project partner in Indo-Swiss International Collaborative Project, and Dr. Tandon is also, possessing excellent track record of publishing top quality research papers in reputed journals on the topic of atmospheric science and climate change. His pioneer work on the status of total ozone column over India has been reported in Assessment of Climate Change over Indian Region, a report of Ministry of Earth Science, Government of India. Now, on this thought, I would like to invite Dr. Tandon to take forward today's event. Sir, you're most welcome.
Thank you, Dr. Priyanka. First of all, my wholehearted gratitude for this invite by Dr. Suraj. So I'm delighted to be here to share whatever little bit experience I have around the dynamics of ozone in atmosphere. So you have actually briefed my journey a bit. So I started my career in atmospheric science by performing statistical analysis of ozone column over India, and we are here today celebrating International Ozone Day. So let me share my screen first. So I hope my screen is visible to all of you. And actually, I tried to get it full screen mode, but somehow I experienced that it is stucking up, and that is why I'm not going to make it a full screen, but 85% zoom. So maybe I'm pretty sure that it is 100% visible to all of you.
Yes.
So,
yes.
Okay. So today I'm just going to share whatever experience I do have since 2003 to 2022 in working in the field of ozone dynamics. And the title I chose to give this particular invited lecture is Understanding Long-Term Variations in Ozone Column over India. So what is ozone and where it is in the atmosphere? So most of us are knowing about all these basic things, but again, as a kind of recap, I'm repeating it. So ozone is an allotrope of oxygen. So it has 3 atoms of oxygen, a triatomic oxygen molecule, and the maximum amount of ozone basically present in the second layer. As far as the thermal profile of atmosphere is concerned, then the second layer from the ground, that is stratosphere, where we get around 10 to 12 ppm of ozone, whereas in the troposphere we don't have that much high amount of ozone, And here ozone basically present in kind of fractional concentration in ppb, parts per billion, and that ranges somewhere between 20 ppb to you can go up to, say, in some acute condition, up to 80 or more than 80 ppb. So what does this ozone layer do for us? So ozone is the only major atmospheric constituent that absorbs significantly between 240 nanometer and 320 nanometer. So we all know about the UV radiations, and we can categorize UV radiations in 3 different categories: UVA, UVB, and UVC. When we are putting wavelength in the decreasing order or energy in the increasing order, so it is the UVB radiation that is basically highly interactive with the biomolecules, and that is why it is also known as thermal UV radiation. And in all of our atmospheric constituents, gaseous constituents, those are present in the Earth's atmosphere, ozone is the only major atmospheric constituent that has its absorption band in 240 nanometer to 320 nanometer, and that is why it is screening off UVB radiation while reaching to the surface of the Earth and making the planet Earth habitable. So without it, life would have been remained underwater. And the ozone layer, the formation of ozone layer is a consequence of ozone-only chemistry. It formed once photosynthetic marine organisms like cyanobacteria began polluting the atmosphere with oxygen. Why I am saying polluting the atmosphere? Because the early atmosphere was not oxygen rich, it was anoxic, and with the evolution of these photosynthetic marine organisms, cyanobacteria, so oxygen was getting emitted in the Earth's atmosphere, and after certain point of time, we found our ozone layer, and after that only the terrestrial life became possible. So moving further, why do we care about atmospheric ozone? Dr. Suraj has briefed a bit about it. Moving further, so it is the presence of ozone in stratosphere that basically modulates the solar radiation that is reaching the Earth's surface. As I said, so ozone is a filter for UVB radiation. So obviously it is filtering out UVB radiation. You can see in the illustration that so whatever amount we do receive at the top of the atmosphere, almost 90 to 95% has been filtered out by the ozone layer present in the stratosphere. So it impacts significantly the trace gases based atmospheric chemistry and photochemistry, because atmospheric chemistry has 2 different mechanisms of reactions, either photochemical reactions or the thermochemical reactions, and photochemical reactions are dependent on the quality and the quantity of photons. So when some kind of filter is there up in the atmosphere, then obviously the kind of photons those are reaching to the surface will be modulated or will be filtered off, and ozone is doing the same. Whenever we are studying about the thermal profile of the Earth's atmosphere, what we do find that in stratosphere, temperature increases with increase in altitude. So this increase in temperature is basically termed as or characterized as the inverted temperature profile, because temperature should reduce with increase in altitude. So it's a kind of universal fact that temperature should reduce. Why it should reduce? Because reduction in the mass of atmospheric column lying overhead at a particular altitude or level, and that should be reflected in terms of the mass density and in terms of the atmospheric pressure. And with reduction in atmospheric pressure, temperature should reduce down. But because of the formation and destruction of ozone in the stratosphere, our second layer of atmosphere, that is stratosphere, has a kind of inverted temperature profile. So any decrease in ozone column content is followed by proportional increase in solar ultraviolet radiation reaching the ground. Why? Because you are thinning off the filter that is filtering out so possibly dangerous solar radiation, that is UVB radiation. So, and it has been established that 1% decrease in the total ozone column can be translated in 2% increase in the surface level UV radiation. So these are some points for which we do care about the atmospheric ozone. So the solar UV radiation that reaches the Earth's surface is strongly screened by stratospheric ozone. This absorption of UV by ozone layer imparts an inverted temperature profile. Biologically important UV are UV and UVB. Human exposure to UVB increases the risk of skin cancer, cataract, and suppressed immune system. UVB exposure can also damage terrestrial plant life, single cell organisms, and ecosystem. Both UV and UVB are scattered by air molecules and aerosols, while the UVB is also significantly absorbed by the ozone. So in general, 1% decline in the total ozone column is proportional to 2% increase in UVB. By the way, what is total ozone column? Total ozone column is the column of amount of ozone that is present in a column of atmosphere from the surface of the Earth till the top of the atmosphere. And we are using Dobson units to give a kind of feel about its amount or magnitude. And what is Dobson unit? So as we know that as we move up from the surface of the Earth till the top of the atmosphere, temperature and pressure varies. So to simplify our life, what we are doing, we are assuming that if by some mechanism we can compress the whole amount of ozone that is present in a column of unit cross-sectional area from the surface of the Earth till the top of the atmosphere at a standard temperature and pressure, then 1 millimeter thickness of the layer that will be constituted of only ozone molecules will represent 100 Dobson units. So in all, over the surface of the Earth, we do have somewhere around, on an average, 300 or 320 Dobson units of ozone in the total ozone column. And you can imagine that how thin is our ozone layer. So it will constitute just a 3 millimeter thick layer and up in the atmosphere somewhere at 30 kilometers or 35 kilometers in the stratosphere. So back in 1983, Forman et al. Discovered the most famous ozone hole over Antarctica while working on Halley Bay in the British Antarctic Expedition Center or station, you can say. And from there, this journey started that we are getting ozone hole over the southern pole in every spring season in the southern hemisphere. So, and then it led to a huge scientific intervention to study that why it is happening, how it is happening, and how large it is, and that basically culminated in the form of your Vienna Convention and Montreal Protocol. Montreal Protocol is obviously successful in reducing down the concentration of ozone depleting substances, in controlling the emission of ozone depleting substances. And then it was thought that at some point of time, somewhere between 1998 and 2001, we'll get a kind of recovery, either signs of recovery or absolute recovery in the content of ozone or in the total ozone column over different parts of the world. But even now, this problem is still relevant. So I have put a couple of publications. Those are the evidences that this depletion of stratospheric ozone is still relevant. So on the left hand side, you can just read it out, that rare ozone hole opens the Arctic. So it started from the Antarctic circle, and now it has reaches to the Arctic circle also. And similarly, the Antarctic ozone hole is one of the biggest and deepest in recent years. So these reports are of 2020. In this particular year, a kind of bombshell was dropped by this particular study with the title that observation of large and all-season ozone losses over the tropics. So earlier it used to be thought of that this problem of ozone depletion is basically limited to the mid latitudes or higher latitudes and not that great in the tropics. But this particular study is now pinpointed the need to study ozone and dynamics of ozone in the tropical areas also. So I started my journey with a thought process that way back in 2004 itself, World Meteorological Organization that keeps on publishing some kind of report with the title that status of ozone column. So that report basically highlighted one fact, that there is no statistically significant trend as far as tropics are concerned. And when we are considering tropics, that it is 30 degrees south and 30 degrees north. So we thought that why don't we check it for the Indian subcontinent, because people were working in India and people were reporting huge losses, huge trends, but World Meteorological Organization or the global scientific community was not accepting that, and basically coming up with the thought that we are not getting any statistically significant trend in total ozone column over the tropics. So why do we have this kind of large scale variability in total ozone column? So total ozone column over a given location on a given day depends on two things. One is its photochemical production and decomposition, and another thing is its influx or efflux. So question can come in your mind that ozone has three atoms of oxygen. Its molecular weight is not exactly 48, not somewhere 48, whereas the apparent molecular weight of the dry air, considering the dry air with 78.1% of diatomic nitrogen, 20.8% of diatomic oxygen, and 0.9% of argon, comes to somewhere around 28.97 or 29. So ozone is heavier, but it is still the ozone layer we found in stratosphere. So why it is so up in the atmosphere? Because we know that the formation of ozone needs further highly energetic photons. So it is oxygen that basically dissociates up into atoms by absorbing a highly energetic UVC photon between 180, having wavelength between 180 nanometer to 240 nanometer. And with the absorption of that photon, it photolizes, and then the atomic oxygen in its triplet state, in its ground state, reacts with the diatomic oxygen molecule, that is our normal oxygen, in the presence of third body, and forms ozone. But ozone itself is prone to be photodissociated with UVB photons. And if we look into the solar radiation that reaches the top of the atmosphere, then we'll get to know that the number of photons crossing per unit cross-sectional area at the top of the atmosphere for UVB is far more in comparison to UVC. So obviously, to get the net production of ozone over a particular place, it has to be transported. It has to be transported downwardly. It has to be transported from the production zone that is in the tropics, because in the tropics, we receive some more or excess amount of solar radiation in comparison to the mid latitudes, in comparison to the polar area. So it has to be transported, like the newly produced ozone molecule has to be transported downwardly and polewardly. So downward transport is happening because of its mass. It is heavier than the average air molecule, and that is why obviously the production is happening somewhere at 50 kilometers high, but we are getting the maximum concentration somewhere at 30-35 kilometers, in terms of number density at 25 kilometers. And as far as the latitudinal spread is concerned, then we are getting the maximum amount of total ozone column in the mid latitudes. So why long-term variability? Long-term variability that we basically observe in the time series data of total ozone column is because of two things: either its production and destruction mechanism or its transportation mechanism. So long-term variability in TOC depends on the annual variability in the solar UV flux. Obviously, we need ultraviolet radiation for the photodissociation of oxygen. Then the long-term variability in the solar activity, that is the sunspot cycle or the solar cycle. We do have information that the solar activity shows some kind of cyclic behavior, and it has a time period of between 9 to 13 years, that the number of sunspots popping up over the surface of the earth or over the chromophore of the sun varies from year to year. So it reaches to its maximum number and again to the minimum number within the time period of 9 to 13 years. And that constitutes your solar cycle. Then there are some other atmospheric cycles, oceanic and atmospheric cycles. Those are basically affecting its transport. It transport downwardly from the 50 kilometer to 30 or 35 kilometer or 25 kilometer, means from the upper stratosphere to the middle or lower stratosphere, as well as the transport from the tropical region towards the mid-latitudinal or higher polar region. So these cycles are, number one is quasi-biennial oscillation. These oscillations are the oscillations present in the zonal wind in the middle stratosphere. So in mid stratosphere, what are the zonal winds? Zonal winds means when we are say averaging out the meridional component for a particular latitudinal band. So these are the equatorial zonal winds. And what kind of oscillation we do get? We get oscillations in its strength as well as in its directions. So within 2.5 years, somewhere between say 24 months to 30 months on an average, in 27 months. So the strength and the direction of these equatorial zonal winds varies between strongest westerlies to strongest easterlies. Westerlies means when the winds are coming from the west, and easterlies winds are when the winds are coming from the east. Then the presence of stratospheric aerosols are also imparting certain kind of variability in the total ozone column. Why? Because stratospheric aerosols are mainly having scattering properties and reducing down or chopping off the incoming solar radiations, solar UVC flux, and that is why it has its implications on the production as well as the destruction of ozone in the stratosphere. Then lastly, why we do get this thinning of ozone layer in the in the spring season over the Arctic Circle or over the Antarctic Circle is basically attributed to the concentration of ozone depleting substances. Earlier, it was thought that it is the emissions from the jet engines, those were flying in the stratosphere, the Concorde fleet, and all supersonic jet engines, and their emissions in the form of oxides of nitrogen. But afterwards, it was realized that, say, the wonder chemicals, those were discovered by DuPont with the name of Teflon or like chlorofluorocarbons. So they are basically inert in tropospheric conditions, but this inert nature gives them or imparts in them very long life, and such a long life that they can be intermixed between the hemisphere and intermixed between the two layers of atmosphere. And once they reach into the stratosphere, with the interaction with highly energetic UVC or UVB photons, they produce halogen radicals, and these halogen radicals, either the chlorine radicals or the bromine radicals, these halogen radicals are acting like a catalyst in depleting the ozone in the stratosphere. So it is the concentration of ozone depleting substances, and ozone depleting substances increased from its inception, from its year of production till the effectiveness of our Montreal Protocol. So it reached its peak somewhere around 1997 or so, and afterwards we have observed that the concentration of ozone depleting substances as a measure of success of the Montreal Protocol keeps on decreasing in the Earth's atmosphere, in the stratosphere. So we are taking this ESC, that is effective equivalent stratospheric chlorine concentration, as a proxy for ozone depleting substances when we need to study the long-term variability in total ozone column over a particular place and attributing it. So we started our journey first with the detecting the trend. So we are terming it as DNA, detection and attribution. And now we have added one more term, that is apportioning it. So we started our journey by reporting statistically significant trend exist over Indian subcontinent beyond 25 degree north latitude. So in peninsular part, we were not observed any statistically significant trend when we worked on this multi-sensor reanalysis total ozone column time series data for the time period starting from the January of 1979 until the December of 2008. But beyond the 25 degree north, we observed statistically significant trend in total ozone column. And this was the first credible report that harnessed the method used by the scientific community in the West, and that is why they accepted it, and it reflected in our report also, the report of Ministry of Earth Science. So if you look into the left panel, then the time span of the time series was from January 1979 to 1993, just 15 years. So in these 15 years, if you look at the numbers, then you will get that the percentage decline in the total ozone column was very large. But as we moved from further up to the 2008, then this decline basically uh, reduced in terms of its magnitude. So the percentage per decade decline in the total ozone column reduced from somewhere around 2.5% to just 0.8 or 1.5%. But the area over which we were able to detect statistically significant declining trend increased. So up to 1993, the statistically significant trend were reported, say till 28° north, but up to 2008, it has been observed that the large part of area, like 40% area of Indian subcontinent geographical area, witnessed statistically significant decline in the total ozone column. So this was the first step in our study where we basically detected statistically significant trend. Then we further moved to attribute these trends. So these are some implications we are knowing. I have discussed that 1% decline will be translated in 2% increase in the UVB radiation, and the increase in UVB radiation has its own effect in terms of its implication on the human health as well as the biodiversity. So after detecting the trends, we actually tried to attribute it. We were knowing that the major role were played by the ozone depleting substances, but we hypothesized that it is the dimming in the solar activity or decrease in the solar activity for that particular time period in that particular solar cycle has something in this decline in the total ozone column. So we again detected the trend. Now we have increased the length of the time series from 2008 to 2012. The start point was the same. Data set was much improved. Earlier, the data set was having a spatial resolution of 1 degree and 1.5 degree. And now we are getting, say, this MSR, multisensory analysis total ozone column data with a resolution of 0.5 degree. And the time series has, obviously, they were keep on adding year and year. So in this particular work published in 2017, we harnessed or accessed the data up to 2012. And again, we witnessed almost the same thing, that there is statistically significant decline in the total ozone column over the Indian subcontinent beyond 25° north. Interestingly, we got some signs of positive trend in the peninsular part. So if you look into the peninsular part, you will get the patches of dark red color or lighter red color, and those are basically depicting the positive trend or the increasing trend in the total ozone column. But in the 40% area over the Indo-Gangetic plain or over the northwestern part, over the Himalayan region, we were having this declining trend present. So then we tried to explain it, tried to attribute it. So what we did, we harnessed or accessed the time series data for the same length for the effective equivalent stratospheric chlorine akin to the ozone depleting substances, the upper panel, and the lower panel is showing you the time series data set for the solar flux. We performed the additive time series decomposition analysis, and from there we just took off one component, that is the long-term trend, and you can see that the long-term trend in ozone depleting substances were positive and it was negative as far as the solar flux is concerned. Then we tried to perform some multiple linear regression analysis and come up with kind of conclusion that ozone depleting substances are imparting 85% declining trend in the total ozone column over the Indian subcontinent beyond the Tropic of Cancer, whereas decrease in the solar activity accounted for the 15% of the estimated negative long-term linear trend in total ozone column over subtropical Indian region. Subsequent to that, subsequent to that, what we like the question that came into our mind that yes, okay, so we have established the declining trend. We have actually attributed it to the decline, to the increase in the ozone depleting substances and to the decline in the solar flux. But in the total column of ozone from the surface of the Earth till the top of the atmosphere, actually where this particular trend exists. So then we went for the apportioning the long-term trend in total ozone column. So now for this particular study, we have taken solar backscattered UV MERS data set for 41 years time period, starting from 1979 up to 2019. And then we divided this total time series into almost equal parts, one up to 1998 and another time series was for beyond 1998 period. So the term we have used the pre-inflection and the post-inflection time spans. So pre-inflection means, as I told you, that we have observed the maximum concentration of ozone depleting substances somewhere at the end of 1997 or so, and after that the concentration of ozone depleting substances started declining. So that was the inflection point. So taking that, like taking December 1998 as the inflection point, we basically chopped off our time series in two different parts. Okay, so what kind of time series data? So here we basically harness the profile data of ozone column present in different layers of the total ozone column, from the surface layer to the lower stratospheric layer, middle stratospheric layer, and the upper stratospheric layer. So the aim was to know about that where basically this trend in total ozone column exists. So when we analyze this data, then what we got to know that during the pre-inflection period, so the color bar basically shows, reddish color is showing you the declining trend, whereas the bluish color is showing you the increasing trend. So if you look into the bottom two panels for the pre-inflection and post-inflection period, and if you look at the y-axis, so y-axis is basically giving you a feel of the altitude in terms of the pressure levels. We can convert the altitude in terms of the pressure levels or pressure levels in terms of the altitude. So if you will get a feel that during the pre-inflection period, like up to 1998, so ozone was declining almost everywhere as far as the total ozone column is concerned. So in mid-stratosphere, it was a huge decline. So very dark red color band you can see. And even in the bottom layer, like lower stratosphere and the surface layer, you can have almost similar kind of feel. It is so the layers between the lower part of mid stratosphere and upper part of lower stratosphere, where there was no statistically significant trend exist. In contrast to that, if you look into the post-inflection period, then you will get a kind of bluish patch between 4 to, then the bluish patch in the surface layer, and the reddish patch is still there in the area between 41 hectopascals to 10 hectopascals. Okay, so what it is all? So during the post-inflection year time span, the long-term trends in total ozone column were still negative over 1/3 of the subtropical region. So here we not limited ourselves just for the Indian subcontinent, but we took the data for the tropical region across the world, moving from say 35 degrees south to 35 degrees north. So this data set has a resolution of 5 degrees by 5 degrees. No, not 5 degrees by 5 degrees. These are the average data. So 5 degrees in terms of the latitude. So what we observed, so in the subtropical region, still we have declining trends in the total ozone column. And within total ozone column, so where do it basically exist? So during this time span, post-inflection time span, where it was expected that we should get some kind of sign in terms of the reversal in the trend or recovery in the total ozone column. So we obviously got some positive trends in the upper stratospheric subcolumn, but the negative trend in the ozone content persisted in the mid and lower stratosphere. So what does it mean? If you look into the profiled constitution of this total ozone column, so almost 50% of the amount of the total ozone column present in your mid stratosphere, some 20% present in the lower stratosphere, some 10 to 15% present in the surface layer, and rest is present in the upper part of stratosphere. So obviously, in the upper part of the stratosphere, we observe positive trend in the post-inflection time period. But in the middle part and the lower part, where almost 65 to 70% of ozone present in ozone column extending from the surface till the top of the atmosphere, that part is still showing a statistically significant negative trend. One more interesting finding of this particular work was to note that the ozone content confined in the near surface layer manifested a strong positive trend in the post-inflection period. So if you look in a kind of combined picture, so we are getting the positive trend or increase in the ozone content present in the upper stratosphere. Then in the middle and lower stratosphere, decline is there. Then again in the surface layer, there is an increase. So in all, if you look in the totality, then these contrasting trends like positive trend in upper stratosphere and declining trend in middle and lower stratosphere, and again positive trend in upper stratosphere, is basically confounding any clear sign of recovery in total ozone column. What has been quoted in bold and in red color is really very, very important. What it is showing, so on one hand, in the total ozone column, we are getting negative trend just for the 1/3 of the subtropical region. Why? Because we are not getting any clear signs, any statistically significant trend, whether it is declining or increasing. But when we are apportioning it, when we are sectioning it out in different layers of the atmosphere, then what we are getting? We are getting declining trends in the middle stratosphere and increasing trend in the surface layer. I would like to remind you that the ozone that is present in the middle stratosphere or in the stratosphere is considered as the good ozone because it is filtering out the UVB radiation. Okay, so this declining trend in the middle stratosphere is basically showing you that we are getting increased amount of UV radiation still up to at least 2019. And now, what kind of implication this increasing trend in near surface layer or ozone content has? In the troposphere, in the surface layer of atmosphere, ozone is considered as bad ozone because it is a pollutant. It is a criteria pollutant. It is an oxidant, and it causes ozone that is present in the surface layer in the troposphere. It causes health implications. It causes irritation to our lungs, to our eyes. It is having implications for the life, both human life as well as the plant, any other animals and the plant life, and has economic implications also because it is a potential oxidant, so it can reduce down the life of different material present in the surface layer. So on one hand, total ozone column is not giving us any kind of clue about the trend, but when we are apportioning it off, then we are getting something very dangerous signs, because in middle stratosphere, so ozone is declining, and in the lower part of stratosphere, ozone is increasing, and these two contrasting trends are basically confounding any trend that is present in total ozone column. So we are getting happy to know that the total ozone column is not showing any trend, so it is a kind of sign of recovery. But let me remind you, it is not a sign of recovery. It is something confounded, and we need to extract, we need to disentangle it out. So now here comes to the coupling between, say, the global warming and ozone depletion, because my teachers used to say that atmosphere is the processes in atmosphere are highly coupled and non-linear. So we cannot isolate the dynamics of ozone from the ongoing climate change or global warming. We all know, and it has been established, that the surface air temperature has been increasing. So obviously the surface layer is warming up, and that is basically our global warming. But if the planet Earth has to be in a kind of thermodynamic equilibrium, then some layer should be cooled down. So it is our stratosphere that is cooling down. And why it is cooling down? Because of the decline in the stratospheric ozone content. So whatever amount by which our surface layer is increasing up, with a similar magnitude, your middle atmosphere is cooling down. So this is the link or the coupling between these two big phenomena in the atmospheric science. On one hand, it is the climate change or the global warming, and on the other side, it is the ozone depletion. So we have seen that ozone is a greenhouse gas, and it has its own radiative forcing, and Intergovernmental Panel on Climate Change has come up with the reports that yes, decrease in the stratosphere has a negative radiative forcing or the cooling effect, whereas the increase in the surface or the tropospheric ozone content has the positive radiative forcing or the warming effect. What about the ozone depleting substances? And this report only I mentioned that scientific assessment of ozone depletion. So I started my journey from 2004. So 2004, then 8, then 12. I think it was 2002, 2, 6, 10, 14, and 18. So this is and 22 will come up. So this is the latest one. You can download this if you wish to know more about the ozone and the dynamics of ozone in the Earth's atmosphere. So here you can see that yes, the as a success of effective implementation of Montreal Protocol, you can observe a continuous decline in the ozone depleting substances concentration in the Earth's atmosphere after 1997 or so. But as far as the total ozone column is concerned, the signs is still confounding. We are not clear. So no statistical significant trend in the total ozone column. I said it, but why it is not? Because of contrasting trends. Whereas we are it has been expected to get this Antarctic ozone hole filled by 2060s. Who knows what is going to happen? Arctic spring total ozone column is expected to return to the 1980 values by 2030s. And then outside Antarctic circle, CO2, methane, and nitrous oxide will be the main driver of stratospheric ozone change or ozone depletion second half of the 21st. These are some conclusions from this scientific assessment on ozone depletion report 2018. So we are still getting some long-term variability, and signs are confounding. Martin Chipperfield, a leader in this particular field, he published this Nature article. And what you can see, what I want to emphasize here, that if you look at the boundaries of the estimated trend, then these boundaries are very large. And these boundaries are very, very large in the trend, that those were estimated in the total ozone column over different regions on the planet Earth, in the mid and upper latitudes of southern hemisphere, of northern hemisphere, and over the polar region. So the challenge for the recovery of ozone layer, so we can say with certainty that Montreal Protocol is successful, and whatever kind of ozone depleting substances covered in Montreal Protocol, their concentration has been declining since 1997, 1998. But there are other ozone depleting substances. There are some certain short-lived anthropogenic ozone depleting substances. Those has not been covered in the Montreal Protocol. Their concentration has been increasing. So this particular paper published in Nature Geoscience put a kind of perspective that we are not going to get any clear sign of ozone recovery till 2050 or so. So the key questions related to the coupling of ozone, climate change, or you can say the ozone dynamics as of day now. So how do ozone changes influence the climate of stratosphere and troposphere? What is the influence of climate change in troposphere on the stratospheric ozone layer? How will the cooling of stratosphere due to the warming of troposphere influences the stratospheric ozone layer? And how can we disentangle the influence of climate change on stratospheric ozone layer level from the influence of ozone depleting substances? As we are knowing that the concentration of greenhouse gases has been increasing, ozone depleting substances are potential greenhouse gases. Chlorofluorocarbon are very long-lived greenhouse gases. So when they are present in troposphere, obviously they are acting as a greenhouse gas. They are increasing the surface air temperature. And again, as I said, to counterbalance that increasing trend, one layer, that your middle layer or stratospheric layer, has to cool down. So this cooling down of stratosphere, or this balancing exercise, what kind of influence it has on the atmospheric dynamics in totality? Thanks for your patience listening to me, and questions, if any, please.
Thank you so much, sir. It was actually very scintillating and a very informative session that we have, and we've learned quite a lot through your presentation, sir. So there are a few questions by the participants that they have put up. Many of the questions I think you have covered in your presentations, but there are few doubts here. Like, what are the reasons of increase in the ozone at the surface level? Ozone layer at the surface. What are the reasons? What are the factors that are contributing to the increase of this?
This is a very good question. So this increase in the surface level ozone content is because of more anthropogenic emissions in the form of ozone precursors. So the mechanism of formation of ozone in troposphere is different from the mechanism of formation of ozone in stratosphere. In stratosphere, it is because of the photolysis of oxygen, and in troposphere, it is because of the photolysis of nitrogen dioxide. So we do require NOx, that is nitrogen dioxide, NO plus NO2. Obviously, atmosphere is oxygenic, atmosphere is oxidizing. So whatever comes into the atmosphere, it will get oxidized. So it is the NO2 that photolyzes and gives us O3P, the atom of ozone in its triplet state, in its ground state, and this O3P reacts with the molecular oxygen and produces ozone. Then the second precursor is volatile organic compounds, or VOCs. And so the increased emission of these two precursors, along with increase in the air temperature, is responsible for increased amount of ozone present in surface atmosphere, to my understanding.
Okay. So now this could be the reason, that is the the change of the trend that you have been discussing in this presentation, that the middle stratosphere, the change of the depletion of the ozone layer is happening. So this is the main basically main reason behind the depletion of there in the stratosphere.
So in the stratosphere, if you look in the concentration of ozone depleting substances, we must have heard one concept of limiting factor. So actually the concentration keeps on declining as far as the concentration of ozone depleting substances in the stratosphere is concerned. But it has not reached a level where it will not impart a declining trend in ozone present in middle or lower part of stratosphere. So still lots of ozone depleting substances are present in the stratosphere, and that is why in middle and lower stratosphere, still we have statistically significant decline in the ozone content.
So how do we reduce this ozone at the surface level?
So surface level ozone reduction will be possible by switching up towards the non-renewable energy resources. We are still in that process. We have started harnessing wind energy and solar energy, and also Rajasthan is leader in that. So future is good, in my opinion.
Okay. Okay, thank you, sir. So now, so you were, mentioning about the Montreal Protocol. So how this Montreal, protocol has helped in expanding this, ozone layer depletion substances in the atmosphere? How this protocol has helped in?
Protocol helped a lot. Protocol is 100% successful. So whatever chemicals those has been listed in that protocol. So with the successful or effective implementation of Montreal Protocol, we have observed it has been established that their concentration keeps on declining. But there are certain other chemical constituents, those have not been incorporated. So it is a kind of dynamic process. I'm pretty sure that the ozone managers conference of this year's UNEP held in Nairobi, actually they were considering to include this chloroform and tetrachloromethane. These are the two short-lived ozone depleting substances. Those were not earlier in the Montreal Protocol. So they are considering it to include, so that we can have a kind of check over their emissions also.
Thank you, sir. So there's another question. Why has an ozone hole or a depletion observed over Antarctic, region, when there is a ozone depleting substances present all throughout the stratospheric layer over the globe?
See, we are reading it in our textbooks of environmental chemistry or so, that this large scale depletion over the polar atmosphere is because of the role of polar stratospheric clouds. So the polar stratospheric clouds are basically providing the surface for the reservoir species and for the heterogeneous reaction. So polar stratospheric conditions, whether in Antarctic Circle or in Arctic Circle, is altogether different from the stratospheric conditions of mid latitudes or the tropical region. And yes, this is 100% true that these ozone depleting substances are present uniformly in the stratosphere over the globe, but they are having they are getting the right platform to deplete the ozone content, and that too in spring season over the poles itself. So I'm not going to get in the more details.
So there is another question by Pranesh. He's asking that what are the products to be used instead of ODS for maintaining daily life?
So research, to my knowledge, research is on. So we moved from the chlorofluorocarbon to hydrochlorofluorocarbon, then got to know that it is again not very good substance. Then we moved from the chlorofluoro to chlorobromocarbon. So obviously the scientists are working on that. So I'm pretty sure that they will come up with some very good compounds. Those are basically used in the refrigerator, or as an refrigerant, or as an propellant in for the aerosols, uh, instead of these ozone depleting substances.
Thank you so much, sir. So last question. Sergeant Thakur wants to know, like, which data sets are used to observe or analyze the ozone depletions?
Again, very good question. So there are different types of data sets present. So if you are interested in the total ozone column, then go for the multi-sensor reanalysis total ozone column data present at the web page of TEMIS of KNMI. So it is the Dutch Meteorological Institute. So you will get the TEMIS and the multi-sensor reanalysis data. If you look into my publications, you will get the link also. If you are interested in working on the profile data, then again, there are different types of profile data sets exist provided by NASA and NOAA. These are solar backscattered UV data sets, and the link again you can get in my publications, or simply googling it up and just putting the SBUV ozone products.
Thank you, sir. We had actually a very informative session, and I hope all the participants have enjoyed, because I thoroughly enjoyed your presentation, sir. Thank you so much. So now moving forward to our next speaker, Dr. Sushil Kumar Shukla, Assistant Professor, Department of Transport Science and Technology, School of Engineering and Technology, Central University, Jharkhand, Ranchi. Dr. Sushil Kumar Shukla was awarded PhD in Environmental Science and Technology from IIT BHU, and he did his MSc in Environmental Science from Allahabad University, and Environmental Science Diploma in Industrial Safety from AIMS Chennai. His area of interest comprises of industrial waste, water treatment, cleaner technology, biofuel, bioformation, and also photo recommendation and air and noise pollution and watershed management. Dr. Shukla has various experiences, as he has worked as a coordinator of Department of Transport Science and Technology at Jharkhand, and he has also worked as an assistant professor at the Department of Environmental Science, Central University, Jharkhand. He has also worked as a coordinator of environmental science in Jharkhand from February 2013 to 2013. Now he is a recipient of several scholarships and honors, like Dr. Shukla was a senior research fellow in UGC from March 2008 to 2011, and he has been recipient of UGC research fellowship for science meritorious student, and then he has retained this scholarship for fellowship, and in the year of 2007 and March 2008. He has received Best Paper Award in national conferences and emerging environmental challenges and sustainable development, organized many conferences and seminars and workshops, and he has been members to many several organizations, like senior member as an Asia Pacific Chemical, Biological and Environmental Engineering Society, lifetime member as a Professor H.S. Srivastava Foundation for Science and Society, Lucknow, and he has several research papers in reputed national and international journals and book chapters in reputed publication houses. On this thought, I would like to invite Dr. Sushil Kumar Shukla to take forward today's event. Sir, you're most welcome.
Thank you very much, Dinka, and I give thanks to all the organizers, especially Dr. Suraj Singh, who called me for this celebration of the International Ozone Day 2022 in the Gyan Vihar University. And I'm happy because in 2012 and 13, we and Suraj Singh both have organized this Ozone Day celebration in Central University of Jharkhand. And today he is the organizer and I am the speaker. This is the journey of our evolutions, and we met at the different platforms. We met at this online platform, and we have selected first of all our presentation in front of you. This is the awareness program. So I think I'm not going very scientific details of this ozone layer depletion and other things, because already Dr. Tandon have explained these things very efficiently in front of you. So first of all, my slide is visible.
Yes, sir.
So I presentation mode done, or this one is okay?
So, it would be better, sir, if it is in presentation mode, sir. Otherwise, that we'll move forward with this.
So now this is in the presentation mode?
No, sir. No, sir.
No.
No, sir. So you need to share the entire screen to present it as an presentation mode. Sir.
Okay. It comes.
So it is. The slide has come, but it is not in presentation mode. But then, sir, we'll just move on like this.
Okay. Now it is presentation mode.
Yes, sir. Now it is in presentation mode, sir.
Okay. So now we start this celebration of the Ozone Day 2022, and every year United Nations they set a themes to celebrate this Ozone Day. The reason behind only that we aware the people about the importance of the ozones, and we select the topic because I'm not much expertise in the field of the ozone, but I am the faculty of the environmental science. That's why we understand what is the environmental chemistry and what is the importance of ozone. That's why I select the topic role of ozone in Earth climate machines. And in these years, if you have seen, my slide is moving.
Yes, sir. It is moving, sir.
Okay. So theme of this year is the Montreal Protocol 35s, because the Montreal Protocols has journey of 35 years, and the theme is global cooperation protecting life on Earth, which is the synonyms of the sustainable development. And this sustainable development will be arises after 1972 because at that time the whole world is realized that the environmental degradation is not a area-centric or country-centric problem. This is a global problem which affects each and every person of this Earth planet. But the Mustafa K. Tolba, which is the director of the United Nations Environment Programs, they say that this ozone treaty is the first truly global treaty that offers protection to every single human being. They say these words only because after 1972, we have United Nations organized a different number of conferences and seminars, as well as the participating countries who signed the United Nations signatories. They have enacted different rules and regulations to protect the nature in our countries, but the rate of degradation is more faster as compared to previous times. It says that, it indicates that the technology is not overseed the nature. So that is the time when we think about, this is not the time when we think about only the anthropogenic developments. We think about the development, but this is the ecocentric development, not the anthropocentric development. So every year, 16 September, we have decided for encourages all nations, as well as mainly to the person who the layman person they don't understand to what is the nature chemistry, how they are helpful to protect the life supporting system in our Earth planets, how we have survived, what are the factors they have decided. So the ozone serve as a kind of the shield for the planet and is essential for preserving its ecology. So the theme of 2022 International Ozone Layer is in order to encourage sustainable development. So what is the Earth climate machines and how this is relevance to the ozones? Because in the universe, the nature is provided the different components, and every components and every molecules and everything which present on this nature have its importance. Everyone, they realize these things into the past 2 years back during the corona periods. When a small microscopic organism is stopped, all the activity of the human beings on this Earth planet when we are technology more advanced. So the Earth climate machine is nothing. It is the machine which has received the thermal engines, which receive the heat from the sun and redistributed it on the Earth environment to the coupled of fluid circulation of the atmosphere and the ocean. If we compare this Earth climate machine, our environment to the body of any human beings, if you see the body of any human being is similar like that of our Earth climate machines, because when we not receive the energy, when we not distribute this energy properly, then our machine is not work properly, and that result in the form of the climate change. So three important phenomena will be occurring into the Earth climate machine. First one is the solar constant. What amount of energy received per unit area on this Earth environment is called a solar constant. So larger and larger amount of energy when we receive, then they retain on this Earth planet and they change the climatic condition of this universe. And all of you know that only this planet or of our solar system, possibility of life is present. Reason behind that, because some important gases which are present in very trace amounts, they have provide one blanket and which is sufficient to provide to maintain the temperature on this Earth planet. Second one is called albedo. Albedo is nothing, is a fraction of the light which is scattered into atmosphere without absorbing on the Earth planets. Similarly, in your body, you have received a lot of energy with the help of different types of food and other types of materials. But what amount of energy required for your body, how they are distributing, how they are functioning, and the rest amount of energy we have excreted in the different forms from your body. And last one is the greenhouse effect. These greenhouse effects play a very important role to maintain the climate on this Earth planets. If you compare the greenhouse gases concentrations on the other planets like the Venus, like the Mars, we find out that the concentration of this carbon dioxide and other greenhouse gases are in large amounts. That's why the diurnal variation of temperature, ambient temperature of these planets are too high. That's why the possibility of life is not possible. Now on come on the main parts. Ozone is an important life-saving layers in the stratospheres. Good ozones and the bad ozones. The tropospheric ozone is called as the bad ozones because it is the third most important greenhouse gases, and they are imparting their role into the climate change, as well as because this ozone is very less stable. They are break down into the oxygen and the reactive oxygen atoms. That's why they are the very strong oxidizing agents. They change the different physiological conditions of the human beings as well as the plants. So here the component of the Earth climate machines. If you see the main components of our Earth, we find out that it is made up of the four components: atmosphere, hydrosphere, lithosphere, and biosphere. All of you know these things very well. I try to explain what are the limitations of any component. Every components have a limited boundary. Every components have a limited carrying capacity. When we exceed the pressures, the carrying capacity of any components, then they revolve in terms of the pollution, in terms of the different environmental degradation problems which we are facing nowadays. If we talk about the biospheres, so the biosphere portion will be increases day by day. The population of the whole world is increases day by day. They create pressures for the survival of our day-to-day demands on the existing environmental components, and the environmental components are trying to balance to each other with the help of the redistribution of the energies. So energy which is received on these Earth planets from the sun, they are distributed into the atmosphere, hydrosphere, and lithosphere. And all of you know that the center on the Gyan Vihar is a very unique. Climate change and the water, both are the interrelated to each other. If you see that the water availability on this Earth planet is 3/4 portion is occupied by the water. And these are also present in three forms: solid, liquid, and gas. Similarly, oxygen is also in the triatomic conditions: oxygen, nascent oxygens, oxygen molecules, and the ozones. And both are important into the climate maintenance on this Earth planets. So all are familiar with this, with the help of these figures, and also Dr. Tandon has explained very well about what is the conditions. But I give this figure here only reason behind you understand what are the atmospheric, what are the gaseous composition in the different layer of atmospheres, and how they are helpful to to maintaining the climatic condition on these Earth planets. If we talk about the tropospheres, its height is approximately 0 to 11, 0 to 14 kilometers, depending upon the equator and polars. But the main composition is a nitrogen and oxygen, which constitute 99%, unless 1% is containing argon, methane, ozone, water vapor, and a lot of other gases. In the stratosphere, you have seen nitrogen, oxygen, ozones are the major gases of the stratospheres. And they are playing a very important role in stratosphere in the controlling of some harmful solar radiation which is coming from the sun, the mesosphere and thermospheres. I'm not going in detail. This figure also you are familiar, but they play very important role to maintaining the climate condition on these Earth planets. If climate is not balanced, then the weather of the particular area will be disturbed. When weather is disturbed, the long-term impact of the weather is converted into climate, and climate decides what types of the activities we have done on these areas. So you have seen that the ultimate source of energy on the Earth is the sun. We receive a lot amount of energy from the sun, which is called as short wave radiation. What is short wave radiation? We have explained in the next slide. This short wave radiation is containing some part of ultraviolet lights and the visible lights. When they come on the Earth's surface, some part will be reflected back to the atmosphere, which is not absorbed by the Earth's surface, is called albedo. And the part of albedo is also very important. By changing the climate, by the climate change, by the condition will be destabilized, the optimum condition on this Earth planet will be destabilized. So the possibility of life in a dangerous situations. Today we have give solutions of any problem. Tomorrow it is the problem of the new generations. This is the evolution. And United Nations never says that with the help of the sustainable technology, with the help of the sustainable development practices, we stop the rate of degradation. They say that we have reduced the rate of degradation. That's why the possibility of life on this Earth planet for the longer times. When the energy is absorbed on this Earth planet, the energy will be emitted in the form of the heat or infrared radiation. So one blanket of the gases are present in our atmosphere, which play a very important role and which is similar to the glass mat panel. That's why this effect is called the greenhouse effect, and the increment of temperature of the Earth's surface is called global warming. And these gases are the carbon dioxides, nitrous oxides, methane, water vapor, ozone, CFC, and other types of the ozone depleting substances also act as the greenhouse gases. So when the concentration of these greenhouse gases increases by the industrialization and urbanization, automatically the ambient temperature, the average temperature of Earth's surface increases, and which triggers the stability of life on these Earth planets. So what is ozone? Already this figure you have already understand by Dr. Tandon, but I try to explain what is the bad ozones and what is the good ozones. Bad ozone means the ozone which are present in troposphere, which directly come in contact to our day-to-day lives, and these are more energetic, more have a more oxidizing power. That's why they create lot of health hazards into the human beings. Skin cancers, they create a lot of the problems. Like lot of the lungs problem will be arises by the ozone, because ozone is a precursor, a part of the oxygens. Similarly, they also entering into the plant bodies with the help of the stomata, and they oxidizing the physiological properties. That's why they're retarding the biomass of the particular plants. So a lot of research going in this field. What is the impact of ozone on this tropospheric regions in the parts of the health and the parts of the other activities, and also what is the role of this ozone into the increment of temperature on this Earth planets. Similarly, you have seen these figures. The ozone layer, the largest concentration, in 90% ozones will be lies from 10 to 15 kilometers to 35 to 50 kilometers. Here, the concentration of ozone in the large amounts, and generally the ozone will be measured in the Dobson units. So the approximately 320 to 340 Dobsons at before 1970s. After 1970s, it is decreases and reaching up to the level of 180 Dobson during the Antarctica regions. And this is not the layer. This is the concentration of the gases which are present into this large area of the stratosphere, a lower part of the tropospheres. So the main function of the stratospheric ozone, why it is called, is a good reason behind that. When we see about the electromagnetic spectrum, when you see the electromagnetic spectrum of our solar radiation, we find out that the lights which have wavelength from 0.1 to 0.4 micron meter is considered as the UV lights. The near UV lights and far UV lights. 0.1 to 0.2 micrometer is considered the far UV lights, and 0.2 to 0.4 is considered as the near UV lights. So mainly we have concentrates on the near UV lights because these UV light is further divided into three categories. From 0.2 to 0.28 is considered as a ultraviolet C, 0.28 to 0.31 is considered as ultraviolet B, and 0.31 to 0.4 is considered as ultraviolet A. So this black black areas which you have seen in this figures is a clearly indicate that this is the radiation absorbed, mainly the ultraviolet light which is absorbed by these ozone layers. So when the ozone thinning, the concentration of ozone is less, the part of ultraviolet lights reaches on this Earth planet in the part of the short wave radiation. Generally, the short wave radiations containing the visible lights as well as the ultraviolet C and some part 5% of the ultraviolet B. In this figure, you have clearly understand what is the role of these different three types of the ultraviolet lights. Ultraviolet C is totally absorbed by the ozone layers. Ultraviolet B, some parts reaching on the Earth's surface, and by the thinning of the ozone layers, the concentration or percentage of the ultraviolet B is more along with the short wave radiation which reaching on the Earth's surface. Because it is a low wavelength, so more energetic, that's why they are damaging in terms of the skin cancer, in terms of the other types of the health hazards on the Earth planets. And ultraviolet A is 100% and 95% is absorbed. How this ozone layer is prepared? So for the first time in 1930s, Chapman's, they are giving the mechanisms. Here you have seen the ultraviolet C, they are absorbed by the oxygen molecules which present in the stratospheres. These oxygen are photolytically dissociated into the nascent oxygens. And nascent oxygens are more reactive. That's why they combine to other types of the oxygen molecules. And the M is nothing. It is a third molecule which absorbs energy which is released during the reaction between the oxygen and atomic nascent oxygens. So they are forming the ozone molecules. Ozones are heavier and they are moving in downward directions. So these third molecules are mainly responsible to increase the temperature into the stratospheres, which are increasing from minus 56 degrees centigrade to -2 at the stratopause positions. Further, these ozone molecules will be absorbed into ultraviolet B radiations and they break down into the nascent oxygen and the oxygen molecules. And this reaction will be continuing severally. So the formation and destruction of ozones are naturally controlled by the natures. Why the destruction is more faster? Because some anthropogenic molecules are entering into our stratospheres, which triggers the degradation of ozone in much faster as compared to the natural factors. That's why the thinning of the ozone layer is more faster, and which is observed for the first time at the end of the 1970s when the peoples, they are working in the area of the Antarctica and they observed that the ozone concentration are decreases. And nowadays, the whole parts like Antarctica as well as the Arctica, both are receiving the similar types of the thinnings. The tropospheric bad ozones. Because I am the faculty in the transport science technology, so mainly we correlate the vehicular pollution to the ozone concentration and what are the problem which is associated with the ozones. So all of you know that the major air pollutants which is created by the vehicular pollutions. And nowadays, because the population is increases, so the urbanization, industrialization, along with the motorization is also accelerated into the urban areas as well as the whole developing and developed countries. Everyone is want to make our life more and more comfortable. So more and more comfortable with the help of different types of the gadgets which are using in day-to-day life. But the end product of the fuel, which is fuel combustion inside the vehicular combustion, is a NOx and volatile organic or carbon is the major parts, which is emitted by either the gasoline, either with the diesel, or any other types of the fuels. So this ozone is not the primary pollutant. It is a secondary pollutant which is formed by the reaction between the NOx and volatile organic carbon in presence of heat and sunlight. They are forming the number of the end products in which ozone is the one end product. And this process is called the photochemical smoke. For the first times they recognized in 1941, and after that in 1950s, SGVU estimates they are giving this is the photochemical smoke in which the NOx and volatile carbon, they are forming the ozone molecules. So the ozone is very unstable. They are formed and dissociate regularly. So the concentration of ozone, that's why nowadays in the parts of the water purification system, water treatment system, most of the developed countries, they are using ozonation as a disinfectant in place of the chlorination. Because chlorination have a residual value, they are impacted on the health for the longer times. That's why they are using the ozonation, because the efficiency of ozonation is larger, but they have less residual value and they are more costly. That's why the people of the developing countries, they are not adopting such technologies. So the vehicular and industrial pollution is a source of the NOx and volatile organic matter and finally ozone. So the increment of the different types of the greenhouse gases along with the ozone, they disturb the earth climate machine of this environment. So need of ozone layer protection, because every humans, they want to sun bath, but nowadays if you take the sun bath, you are affected by the different types of diseases. Reason behind that, because our environment is fully polluted. If you go into outside, if you are standing for 1 hour into the any sunlight areas, you have receiving lot of the patches on your skin. This is nothing. This is the part of the climate change, and the huge amount of the solar radiation come on the earth surface and they're retained by the greenhouse gases. That's why the ambient temperature, the intensity of the radiation will be increases. Here, different part is given to what is the functioning of the UVA, UVB, and UVC. People think that the UVA has a no impact on the human health, but they are also responsible to creating lot of damages on your skin, which are clearly shown in these figures. So knowing environment is significant for the reasons. First of all, you understand what are the conditions. Because when you know, when you understand the problem, when you feel the problem, then you give the better solutions. Nowadays, the people who start the research, they don't think about the problem, they don't realize the problem, and they are giving the solution. That's why these solutions are only present into the research paper. They never come on the grassroots levels. So this program, today program, is organized only for the awareness of the every person, not only the literate people, only the non-literate people who are aware about the importance of the ozone and what are the practices we have utilized our day-to-day life by which we can reduce the impact of the environmental degradations. So here we have shown the population trend, because this is the biggest problems which create all problems in our universe. You have compared why the problem will be more faster in after 1970s. Here you have seen that in 1830, the population of whole world is only 1 billion. This is the data of the United Nations World Population Prospects. In 1930, the population reaches 2 billion and they'll take time 100 years. From 1960s, only time 30 years, population reached 3 billions. 1995, time duration 25, but population reached 4 billions. In 2000, the population duration is only 3 years and the population of the whole world is 6.3. At present, the population is reaching approximately 8 billions. And if the current trend is continuing in 21st century, the whole population of the whole world will be expected 16.5 billions. You can imagine when the 8 million populations are present on this our planet, they damage our nature in such a way that the whole universe is not supporting life. So what happens when 16.5 billion people reside on this earth planet? What is the condition of environment? That's why the sustainable development is not the demand. It is a need of the present generation to protect our present for the future generation. This is the actual motto of the sustainable development. Here I try to correlate the ozone productions, the ozone concentration, and the urbanization and the vehicular populations. You have seen out that at the time of the independence in India in 1951, the number of cities with population more than 1 million is only 5. Number of cities with population is more than 0.1 million means the population more than 1 lakh is 42. Means total number of cities in India is 47, which have more than 1 lakh population. But in 2011 census of India, it reaches 468 cities which have population more than 1 lakh. And it is expected that if the census will be occurring in 2021, it is reaching more than 800 cities above the population 1 lakh. So you can imagine when the population migration from rural area to urban areas and the population are accommodated at one places, they create the demand in terms of the standard of life, living standards. Then how we can accommodate the large number of pollutants which are emitted by the such huge amount of population at that concise places is the biggest challenge for the researcher as well as the engineers. Here we have shown the trend of the vehicular populations as a report of the Economic Survey of India 2018-19. Because vehicular population is also play a very important role into the climate change. More than 60% air pollution problem will be arises by the activity of the vehicular pollutions. You can see that what are the conditions and how they are accelerated. In 2011, the total number of registered vehicles in Delhi is 6.3 million, in which include two-wheeler, three-wheeler, four-wheeler, and all things. And total number of registered vehicles in 2019 is reaching 8 million, and at present more than 9 and 9.5 million in New Delhi. Similarly, if you see in the Bangalore, I choose these two states because one is the capital of the India and second is the most emerging cities of the India in terms of the job point of views. So in 2011, 3.01 and 2019, 10.9. Availability of land, availability of road, availability of all these things are limited, but the day-by-day population of the vehicle will be increases. They create the huge vehicular pollution in that area and they increase the ozone concentration in that area also. That's why the chance of the throat infection, chance of the lungs problem, chance of the other types of skin diseases are more accurate in these areas and they increase the ambient temperature of the urban areas as compared to suburban or semi-urban areas. Here we have clearly indicate that what are the trend of the vehicular population in the Bangalore and what is the percentage of the two-wheeler, three-wheeler car and jeeps. So the major percentage which is occupied into the any vehicular pollution is a two-wheeler. So as per the CSC report 2015, exposure to toxic vehicular pollution has a worse in India due to the staggering pace of motorization, with the number of registered vehicles going up 700 times from 0.3 million in 1951 to 2010 million in 2015. Every year in Delhi and other metropolitan cities, you have heard that a lot of environmental problem, air pollution problem will be arises. And people, they are facing a lot of problem during the winter seasons. But when the bright sunshine conditions comes, the dispersal and dilution of the pollutant and we forget the problems. But if we forget today, then one thing is very important of the Aldous Huxley, they say that man do not learn very much from the lesson of the history is the most important of the all lesson of the history. We'll never learn from the history because recently in the Corona call, every people, they are lived in the homes and they are not much health impacted during this Corona periods because they are living into the full homemade environments. When we are going in outside, we have exposed to the external environment, we have inhaled this contaminated air inside your body and they are damaging your health system. Not only you, as well as the plant and other biotic communities are also affected by such types of the environmental problem. So the study by the Center for Science and Environment titled At the Crossroads has revealed that the growing number of the private vehicles without adequate public transport in cities will lock in enormous amount of pollution and carbon. So what is the vehicular fuel combustions? If you see the history of the fuels, we find out that either regularly the policy maker of the country as well as the world, they are changing the type of fuels and type of engines which are using in our vehicles. Earlier, all vehicles, they are fully dependent upon the gasoline and diesel. But nowadays, because if you see the end product of this gasoline and diesels, if only methane is the fuel and they burn into the only oxygen, in pure environment of oxygen, the end product is carbon dioxide and water. And this is acceptable in our natures. But when we are using the gasoline in presence of air, then what happens? Air is containing the mixture of the nitrogen, oxygen, other trace amount of gases. That's why the end product is also containing the major part of the carbon dioxide and water, along with particulate matter, NOx, volatile organic carbon, and trace gases. Here you have seen NOx and VOC is the major component of the fuel combustions in the most of the gasoline and diesel engines. Looking this because this is the main source for the production of the ozone in the tropospheres. And blending of fuels like E20 and B10. E10 means ethanol blending, 20% of ethanol into 80% of the gasoline, and B10 is the biodiesel, 10% of biodiesel into the 90% of diesels up to 2025 to reduce the end product of the to change the end product, because in this blending, the more and more aerobic conversions of the fuel into end products. So shifting of gasoline vehicle to hybrid electric vehicle not is the demand. It is the demand of the present 8 times, because with the help of these types of this technological shifting, we try to reduce the percentage of the NOx and volatile organic carbon, because if this NOx and volatile organic carbon we have reduced, automatically the ozone concentration which is formed by the vehicular pollution is also reduced, and they also act in the temperature balance of that areas. So these are the correlation of the vehicular fuel combustion to the ozone production in tropospheres. So what is the stratospheric ozone depletions? Generally, the ozone depletions occurring in nature continuously. Continuously, they are forming and depleting. But what happened when the man-made chemicals, when man-made substances are entering into the stratosphere, which containing the free chlorines, and this chlorofluorocarbon have a very long span of life into the environment. They more than 100 years, more than 200 years. So when they come in contact to the strong or intense ultraviolet lights at the upper troposphere, then they are break down into the different components and the chlorine is free. So these free chlorines, when combined to ozone molecules, they are forming to the ClO plus O2. This ClO, when combined with the nascent oxygen, they are forming free chlorine per oxygen. This free chlorine and oxygen, they are further deteriorating, degrading the ozone molecules. One chlorine molecule is sufficient to degrade the 1 lakh of the ozone molecules. So you can imagine what is the concentration of the chlorine, how you can measure this thing, what are the chances of the ozone degradation. These are the problems which we are facing into the Antarctica region in 1971. But the people who are working in these areas, they are surprised with the results and they are not confirmed. And after several years of the studies, they confirm that this is the actual problem, this is the actual factor which is responsible for the triggering of the lowering of the stratospheric ozones. Besides these ozone, nitrous oxides, nascent oxygens, hydroxyl free radicals, they are also act as a ozone depleting substances, but these are the naturals, because nitrogen and oxygen are present in stratosphere also. So these are 2 types of the NOx is produced. One is called the fuel NOx, and second one is called thermal NOx. Fuel NOx means when the NOx, nitrogen and oxygen combine in presence of high temperature inside the engine, they are producing NOx as the end product is called the fuel NOx. Sometimes when the temperature of our surrounding is increases, then the nitrogen and oxygen in the atmosphere, they combine together and they form the NOx compound. This is called as the thermal NOx. So by the climate change, when temperature of ambient temperature will be increases, the percentage of NOx is also increases, and they are triggering to the formation of ozone in the future also. So the discovery of the ozone holes, in this figure, you have clearly seen that British Survey of Team, they have shown that in 1957, the average concentrations of the ozone, which is measured in the Dobson units, is approximately more than 330. But after 1971-75, continuously they are decreasing and reaching up to the level of 180. At present, the concentration of this ozone over the Antarctica region is above 220 Dobson. It means they are improving. That's why we are celebrated. We have celebrated this ozone day not only because we have achieved the target in the positive direction. We have celebrated this thing because we think that this is the problem which we have tried to solve with the help of the appropriate mechanism, appropriate awareness program. So if in future we are aware, we save our environment for the longer times. So rate of ozone depletion in Dobson units, you have clearly seen that these after 1960s, their percentage is continuously decreases, and after 2000, they have stabilized and going in upward direction. And hole is generally defined. Hole means this is not the one hole, this is one layer. This is the concentration in that particular patch of the stratosphere from 10 kilometers to 35 kilometers. The concentration of ozone is decreases, so the chance of absorption of ultraviolet B light is decreases. So the percentage of ultraviolet B increases on the Earth's surface. So they are triggering the different types of the atmospheric problem. Here we have shown one slide of the fresh water availability. Because fresh water, water on this Earth planet is also play a very important role in Earth climate machine maintenance. If we remove this water, we change the water, all these 3 states of water also play a very important role into the climatic conditions. I'm not in good detail because all of you are aware from these types of things. So these are challenges of anthropocenic developments and major global environmental problems which are facing day by day. So if we think that these environment not affect to you, it is not the wrong perception about the environment. Everyone which live on this earth planet, if earth planets not provide the basic environment, you can't survive on this earth planets. So what is the need of environmental protection? Three important incidents which I remember in front of you. What are the major challenges? What are the major factors which are responsible for the climate change? Why the people after 1970s, they are more worried about the maintenance of the climates? The first is World War II. In World War II, the first times the use of the atom bomb. And these atom bomb, they are increases the concentration temperature of that area more than 72 degrees Fahrenheit, which destroy the biodiversity as well as the half-life periods of the radioactive material is larger. That's why they are affecting the environment through the longer times. So this is the best example of the greed of the human being, because nature is sufficient to fulfill your need, not your greed. Vietnam War is nothing. This is also one important part where the first time United States military, they use the chemical weapons called the herbicides. With the help of the application of these herbicide, which is called the ranch hand orange, and here more than 5 lakh children are dry, and the healthy ecosystem is converted into the barren land, and that land will be not recovered to till dates. And the last and most important thing is the Sparrow episode of China. These are the best example of the greed of the human being to achieve the goal of development. If you are developed, but the nature is not sufficient, there is no meaning of your development. This is a great leap forward second 5-year plan of the People's Republic of China in the year of 1958 to 1962. There are two ways of the development. Either you reduce the consumption, either you reduce the production. So the 4 pests, mainly the rat, flies, mosquitoes, and sparrow, the campaign started that these are the more 4 pests. They destroy your grains. That's why you have some less availability of the grains. What happened? More than millions of the sparrows, they are killed in 1960s, and they destabilize the ecological balance of that area because the percentage of insects increases, and that results the natural predators are decreases, and the insects will be increases. They destroy the quality of the ecological balance. So more than 15 to 45 million people are dying in these 5 years in China. So automatically they jump from the 1958 to 1962 and achieve the goal of development. So need of sustainable development, because sustainable development is nothing it provides. It says that you do the development along with the conservation of the natural resources, and also provide the quality of life by equitable distribution of wealth and materials. This is the exact motto, but development is inversely proportional to the ecology. So when we start the development, ecology is deteriorated. So such types of awareness program, we try to find out that what are the optimum way by which we can achieve the goal of development. There are different efforts done at the international levels, in which the most important thing is the Montreal Protocol 1987 and Earth Summit Sustainable Development. So till date, in 2015, the United Nations, they set a target to achieve the goal of development on the basis of the environment, religion, and culture, because they understand the technological development is not sufficient to fulfill the demand of sustainable development. Only the awareness of the peoples by which we can achieve the goal of development. This is the Vienna Convention and Montreal Protocol, which play very important roles into the stratospheric ozone depletion, ozone depletion substances removal from the natures. In 1995, 22nd March in Vienna, for the first time, ozone layer was signed, protection of the ozone layer, and the main things which come in 1987 and 16 September, Montreal Protocol, which advocate that the depletion of the ozone depleting substances from the nature is the best way for the ozone protection into the stratospheres. So ODS controlled by the Montreal Protocols. What is the ODS and how they are reduced? So chlorofluorocarbons used in the past in refrigerator, air conditioner, foam, and other products. These are the necessities of our day-to-day life. When temperature increases, automatically the utilization of the refrigeration, utilization of the air conditioners, utilization of other types of the thinnings, because the foam we are using for the fire extinguishers, they are increases. So replace this chlorofluorocarbon totally banned, and the hydrofluorocarbon will be induced into the market. But These hydrochlorofluorocarbons nowadays, they are also act as a global warming agents, as a greenhouse gases. That's why we think about the other types of the materials, other types of the chemicals which are least damaging into the environment. This is a part of your research. We also think about the bromine, because we not studied what are the reactions between the bromine into the nature and how they are doing. But the main part is that because these ozone depleting substances, they exist the longer time into the atmosphere, they're not degraded by the natural conventional mechanism. That's why they destroy the ozone for the longer years. So the phase out mandates of the Montreal protocols, chlorofluorocarbon is totally banned up to 1996 in the developed countries, in the US and Canada. For the developing countries, they have given the times, and up to 2010, 100% phase outs of the chlorofluorocarbons. And after that, they also say that there is no maintenance of the refrigerator or air conditioner which are manufactured beyond that 2010, because they are using the chlorofluorocarbons at that time. Halogens, similarly, the phase out removal from the natures, methyl bromides. So decrease in production of chlorofluorocarbons. In this figure, you have clearly understand that up to 1990s, the chlorofluorocarbons are continuously decreases, and after 2010, totally banned into the whole universe. So the potential impediments to ozone recovery. ODS abundance is falling, but the Montreal Protocol work is not finished. The ozone layer, because we celebrate that the ozone thinning in Antarctica is improving. But same time, the other parts of the Arctic regions, we also receive the similar types of the patches, similar types of thinning. It means the material which we are injected in the larger concentration, so the nature have a limited capacity to accommodate that types of the pollutant. When they exceed the carrying capacity of the nature, they are creating the problem in terms of the climate change, in terms of the other types of the health effects. So the ozone layer remains vulnerable for the long times because of the long lifetime of the many ODS. Halon 1301 and several CFCs emitted from the older equipments are still increasing in the atmosphere, and hydrochlorofluorocarbons are still produced and consumed as permitted during the phase out period. Unusually, the cold temperatures can act as a catalyst, triggering the demanding action of the chlorine and bromine compounds already in the atmosphere. That's why these phenomena are very visible into the colder part, the polar part of our continents. Other factors like the major volcanic eruptions occurs may result in a substantial ozone depletion substances. So the recovery of the ozone layer depends on the full compliance with the protocol restriction on ODS. If not, it would be delay or even prevent the ozone layer recovery. So our international effort to protect the ozone layers remain essential, and we celebrate these types of the program every year to aware the people who are working in these areas, who are not working in the area, but they are aware what are the importance of these types of the products, and they utilize the 3R formulas: reduce, reuse, and the recycling. So the eco-centric development models. This is the time when we think about the eco-centric development model, not the anthropocentric development models. We try to develop such types of the research, such types of the model by which we can save our environment along with the development. So in this area, according to the National Biofuel Policy 2018, India set a target to achieve E10 by 2022 and E20 by 2025. Earlier we set this target 2030, but now the previous 2 months back, our prime ministers, they reduced the target up to 2025. But the condition is not favorable to achieve the target of E20s, because up to 2019, if the total amount of ethanol we have used in the ethanol blending, then we fulfill the demand of only 6.6% of the blend rates. So the major roadmap to achieve this target is that national ethanol production is insufficient to meet the demand because less availability of the raw materials. So nowadays, we have tried Ministry of Highway and Transportation. They promote the green sage development along the highway to reduce the impact of the vehicular pollution, because these trees along the highways, they are act as a barrier in the dispersal of the pollutant. They absorb the pollutant. So we have done a lot of research to what is the impact on these pollutant on these types of the plant, and how we can select the suitable plants which are growing in these areas and which are reducing the atmospheric pollution. Because when vehicular pollution is not traveling to larger distances, so chance of production of ozone is also very less. Thank you.
Thank you
Hello.
so much, sir. Thank you. It was actually a very informative presentation by you, sir, and we are very delighted to have this presentation from your end. So there are a few questions that I would like to ask you, and a few of the students and participants have put up these questions. So one of the question is that do change in solar phase and the volcanic eruption affect the ozone layer?
Ozone layers are two types. One is the stratospheric ozone layers and one is the tropospheric ozone concentration. We have talked now about the layers, the concentration in the ozone into the stratospheres. When they are thinning out, what happens? They are provide the shield, which protect the harmful solar radiation which not reaching on the Earth's surface. When they are thinning, the more and more amount of the ultraviolet lights come on the Earth's surface, and because they are more energetic, more oxidizing powers, that's why they increase the average temperature of the Earth's surface because they change the energy balance on the Earth planet. Secondly, because they also act as a greenhouse gases on the lower atmospheres, so they retain this energy in this atmosphere. So we disrupt the environmental stability of the whole universe. So we think separately what is the condition. One part they are goods, but one part they are not much as good as compared to the stratospheric ozones.
Thank you, sir. Sir, there's another question. How do we know that the natural sources are not, the primary responsible for, depletion of the ozone, and only the anthropogenic,
I
activities?
say that the nature have a certain balance. If one thing is happened in one component of the environment, it is the counterbalance by the other component of the environment. For example, huge amount of energy come on this Earth planets, but our planet have a unique distribution of the resources. Out of 3/4%, the 95.57% is the oceanic waters. Is this water is converted into fresh water? This is important? No, because oceanic water have its importance into the climate control. They absorb more and more amount of the lights, the solar energies, and they re-radiate back into the lesser amount of energy. That's why less amount of water is evaporated by absorbing larger amount of the energy. If you compare from the fresh waters, they are absorbing less energies, but they emitted more amount of the water. But at the same time, the third part of the water is the ice. They also play a very important role because they reflect, they impart the role in the albedo. So all these things have its importance.
Thank you, sir. Sir, is change in agricultural practice and transportation is one of the cause of depletion of ozone layer and the global change?
The change in agricultural practices is only the demand to fulfill, only for fulfill the demand of the people who are living on this Earth planet. We are using the chemical fertilizer to improving the fertility of the soil. But nowadays we are doing the research how we can protect the soil fertility. First we destroy the nature, later we protect the nature. This is the part of the human things. Vehicular population is nothing. This is the demand. It is the demand of the present generation to make our life more and more comfortable. That's why we are taking the private motorization is faster as compared to public transportation. If you go into Delhi and see what is the condition, what is the impact of the metros along with the private motorizations. Every persons, they are parking their private motors and they are using the metros for traveling the larger distances. So this is the part of the government. They provide the policies by which making the public transportation is more easier as compared to the private transportations. So everything is interrelated to each other. If more and more people are residing into the urban areas, the agricultural practices will be destroyed. And if you see the policy of the Manrega, if all people got the job, who is doing the work into the farming land areas? So nowadays, the thing will be reversed. People after getting the degree of the MBA from a different IIM, they are performing the farming. And the people who are doing the farming, they are going into the city areas for doing the job. Because what we have, we never satisfied. We think that what the others have is a good. That is the problem of the human beings. That's why our nature is more degraded as compared to previous times.
There is another, question is that how does the food export and import trend is affecting the global change in the environment as well as in the affecting the.
If you remember that for the first time the Parthenium entered into in India after when the beets come from the America.
Yeah.
So when we have using the different types of the seed materials, why nowadays the preservation of the local seeds? Reason behind that, because this is the specialty of the local environment. They have the specialized, they have the accommodate to survive in this local environment. If we are using the seed of the India to try to germinate into USA and you try to germinate in America, the quality of the soil, the environment, they are totally different. So we have genetically modified these seeds, and these genetically modified seed have a less characters as compared to the previous ones. So nowadays, the GM food is a more dangerous for the human health. And we are moving in the backward sides. We are using the organic food for the health point of view, but this is not acceptable, affordable by the every layman person.
Yes, sir. The traditional knowledge of any.
Without traditional knowledge, you never achieve the development.
Yes.
But the people of India, they think that the development is only come from the developed countries. No, they preserve his culture and after they start development. We forget our culture and try to achieve the goal of development. We never achieve the goal of development. This is my question.
So the key way is to preserve our traditional way so that we can more move towards the sustainable
In the
development.
present time, if you see all the policy of the governments, they try to preserve the traditional practices.
Yes, sir.
Because this is the actual way by which we can save our environment for the longer time in Indian continents. What happened into the Ukraine, what happened into the Russia, this is the part of the greeds. This is not the part of the need.
Yes, sir. Yes, sir.
And nature gives lesson every time, but we never learn from the lesson.
Yes, sir. Yes, sir. Human need can be fulfilled by the earth, but not the greed. Sir, there is another question. Has the global, tourism affect the trend in the rise of change in the climate and the environmental setup and everything?
Definitely, the incident of the Uttarakhand, the incident of Uttarakhand, incident of the Jammu Kashmir, they are the part of the tourism, and according to our tourism facilities, we change the existing environment in our convenience. When we change the environment in our convenience, automatically the nature gives the rewards as per your convenience.
The Dr. Ashutosh Tripathi would like to know that could you please have a more emphasis on the role of iodine chemistry in the ozone depletion?
Actually, I have not done much in the iodine chemistry, so I am not going details. So this is the part of the research, iodine, bromine, and these are the research. What types of the chemical which are using in the replacement of the hydrofluorocarbon, the hydrobromides, and how they are presenting into the natures. The major part is that if any chemical they are destroying by the conventional mechanism of the nature is the fruitful for our present day technological developments. First, we prepared the plastics. Nowadays, we ban the plastics. Now we are thinking about what is the alternative of the plastics. So this is the part of the evolution. This is the part of the research. First, we create the problem. First, we give the solution. Later, this is the problem. Because the ultimate problem is our population.
Sir, there's another question. Has there been any addition to the Montreal Protocol so far as the trend of knowledge and learning has been increasing, the research has been increasing. So along with the increasing research, has there been any addition to the Montreal Protocol, sir?
Every Montreal protocols give the guidelines, and these guidelines follow by all countries of the nation, participating nations. They give the solutions. What are the remedial measures you have taken in your technological developments? If you are using that thing in your policies, automatically the products, we have changes the part in the product concentrations. And without it changing, we never achieve the goal of the development. So Montreal Protocol is only one convention. And every year, every 5 years, we have think, we review what is the achievement and what is the drawback. And they are aware the people by availing such types of the program like the Ozone Day, because every year for one day, if a large number of people who are listening me and as well as that they are doing, thinking about what is the Ozone Day, they understand what is the importance of ozone and how we can save this ozone and what is the importance of ozone for the future months.
Thank you so much, sir. Actually, it was a very scintillating learning process that we have taken up from you. Moving forward with our event, and as we have almost come to the last leg of our event, I would like to invite Dr. Suraj Kumar Singh for the vote of thanks, and then we can move forward, sir.
Hello, thank you, Dr. Priyanka. And today it was a very outstanding session, both the session where Dr. Ankit Tandon from Central University of Himachal Pradesh and Dr. Sushil Kumar Shukla, a close friend of mine, has performed, has given a very in detailed and very energetic talk about all the questionnaire answers. And the purpose of conducting or the celebrating the ozone layer has been achieved as far as the knowledge is concerned, as far as the information is concerned, as far as the technology, how the traditional methods. Dr. Sushil Shukla has given an emphasis on the traditional methods, that we must conserve our traditional methods and then we can add on the technological advancement to it. And Dr. Ankit Tandon has given how the satellite driven or the secondary data where the different statistical analysis has to be performed to understand what are the portion that is cooling. If we are thinking that the ozone depletion has been stopped, so you are in a myth and you have to reconsider your entire process. So we were very fortunate. We thank from our heart Gyan Vihar Center for Climate Change and Water Research that from your busy schedule, you both of us has given us time and you have made the awareness amongst all the students who have listened you. And I also thank the organizer, Dr. Priyanka Roy, Dr. Kaninder Kumar Singh, our coordinator, Dr. Shruti Kanga, Director, Dr. Sudhanshu Sharma, Dr. Gaurav Tripathi, Bhartendu Sajan, who have made this program a grand success. And with this, I will end with the permission of our Honorable Coordinator, Dr. Shruti Kanga. Can we end the session? And thanks, Sushil.
Thank you, sir. Namaste. Thank you, Ankit sir. Thank you, Sushil sir. Thank you, all the participants from Center for Climate Change, and we do accept your, participation in our future events too. Sir, Ankit sir and Sushil sir, your guidance to our students, our scholars, and the department for the further, developments of the center as well as university. Thank you so much.
Thank you, sir. Thank you.
Thank you, ma'am. Thank you all.
Sir, there is a request
my pleasure.
again, sir. I would request all the participants and everyone here to turn on their camera so that we can take a screenshot. All the participants, you are requested to turn on your camera so that we can take a screenshot. Thank you so much. Thank you all.
Namaskar.
Nani.
Okay, thank you.
Thank you. Thank you.
Thank you all.
Thank you, sir.
Thank you, sir.